Hey guys, thanks for stopping by. Let's go ahead and finish up one more example. This is the final example for completing the square. So it says find the x-intercept for the following quadratic by completing the square of y equals x squared plus 4x plus 1. Now if we actually go back to the steps, the first step we're going to do is we're going to start by drawing our tiles. Put the x squared in the top left, separate half of your x's onto the right side, the other half to the bottom of your x squared. So what I did was I took my x squared, my 4x's, and my single one, and I separated my 4x's into two equal groups. That's 2 each. Put 2 on the right and 2 down below. For my 1, I just put it here. It could have been anywhere. And hopefully you guys can see there are some spaces missing for this to be a square. Now, many of you could probably see these spaces and think, oh, there's 3 of them missing, but just in case you can't actually imagine them, let's go ahead and put them in there for you. As you can see, when you put those 3 ones in there, we now have a perfect square. All right, well, that's going to tell us a couple of things. It's going to tell us what was missing. So let's go ahead and add those 3 to both the left and the right side of our equation. So here's our equation. I set the y equal to 0 because we're looking for the x-intercepts. And we can go ahead and add 3 to both sides, since adding 3 to both sides will effectively complete our square. Great. So 0 plus 3 will give us 3. 1 plus 3 will give us 4. So let's go ahead and rewrite this equation. 3 is equal to x squared plus 4x plus 4. Wonderful. So now we have this, we need to factor it. Now factoring, we could use the box and diamond method now because we're dealing with a perfect square, but we actually already know what those outside sides are going to be. So let's actually go back to our model here. We know this long area is going to be x, with each of these shorter areas are going to be 1. So we have an x plus 1 plus 1. Well, 1 plus 1 is 2, so we have an x plus 2 on the top. If we look at the side, there's an x and a 1 and a 1. And of course, that's going to be x plus 2 as well, which shouldn't surprise you guys because this is a square and square sides are all going to be the same in length. So x plus 2 times x plus 2 will give us our shape. So let's write that down. Again, we know that it's going to equal 3, and that's going to be x plus 2 times x plus 2. Well, we know that any time that you multiply something by itself, that's just squaring it. So let's actually make this a little bit simpler. Just change it to a square. Now we have our binomial squared equals 3. Now in order to get rid of this square, we know we're going to have to square root. And we can't just square root one side, we're going to square root both sides. So let's go ahead and see what this looks like when we square root it a little bit. So on the left side, we're going to do the square root of 3 is equal to the square root of x plus 2 squared. Well, we know that the square root and the squared are going to cancel out, leaving us with just x plus 2. But something we might have forgotten to do if I don't bring it up now is that we now know that anytime we square root a number, we need to put a plus minus in front of it. So let's go ahead and change this to a plus minus in front of our root 3. All right, so now we're going to go ahead and do that whole canceling out of the square root and the square. And when we do, we're going to get plus or minus root 3 is equal to x plus 2. Because remember, the root and the square canceled each other out. Well, last step is just to isolate our x. We can do that by subtracting 2 from both sides. So let's go ahead and do that right now. All right, so this positive 2 and this negative 2 will cancel out, effectively giving us x on the right. And negative 2 is just going to be stuck onto the end of this equation. So we have negative 2 plus or minus root 3. Let's write that out in its full form. Negative 2 plus and minus the root of 3 is going to be equal to x. So we now have the square root version of our answer. And it's actually two answers because in one of them we have to add the root of 3 and the other one we have to subtract the root of 3. So what we're going to do is we're going to take this equation and break it apart into two separate equations. Let's do that now. There's our first one with the plus. Let's make our second one now. And now we have both equations. All right, let's actually just, in order to solve each of these, we actually need to find out what the root of 3 is. So let's find out what that is. So we're going to take the number 3 and we're going to square root it. And that's going to give us 1.73. And we'll do the same for the other side. And we now have both of our equations with actual numbers. So let's start with the first one, -2 plus 1.73. So -2 plus 1.73 is going to give us -0.27. Remember, these are x-intercepts, so we're going to say -0.27, comma 0. And for the second one, we're going to take -2, subtract 1.73 equals x. So -2 minus 1.73 gives us -3.73. -3.73, comma 0 is our second x-intercept. So we've effectively found both x-intercepts. Now, don't just trust me on this one. Feel free to use DESMOS to check the work. What we're going to do is we're going to actually plug in our original equation into DESMOS, and we're going to see if our intercepts are the same. So we have x squared plus 4x plus 1, and we get -3.73 approximately, and -0.268, which would round up to -0.27, which is exactly what we found before. All right, guys, thanks for watching.